Working with information represented in a Venn diagram. This presentation focuses on examples on representing given information in a Venn diagram and manipulating information represented in a Venn diagram. Let us recall that in a complete Venn diagram, a rectangle represents the sample space or universal set, and each set is represented by a circle. This is the situation that I'm referring to. TSV are sets, right? And they are subsets of the universal set U, which is the rectangle. So this is a complete Venn diagram. Let us also recall the notation used in sets. I'm not going to go through reading all this, but maybe for this presentation, what is going to be very much used is the union of sets, that is element in either set. Then the intersection of sets, that is elements in both sets, right? Add to that, that is A prime, which is read A complement. That means elements not in set A. Then the N of A is read number of elements in set A. So the S or the U will represent sample space or universal set. That is all things we are interested in. So I think these are the ones that I'm going to frequently use in this presentation, but all the same, it is wise for one to know the meaning of these notations when it comes to dealing with sets. Also important reminder is two ways of writing one and the same thing. Write A union B can also be written as A or B. That means the union sign can be substituted by the word or, right? So again, to mean elements in either A or B. So you are bringing them together. Then A intersection B is also written as A and B, right? So all what it means is we are saying elements in both the sets A and B, and this is important. Then A prime can also be represented as not in A. So A prime is A complement, but if one writes not A, simply means elements not in set A. That is important. Okay. Let us look at this example number one. Given the sets U, A, and B, the U represent the universal set. These are subsets, right? We want to represent these sets in a Venn diagram. After that, then we answer B up to F. So as a starting point, we are having this diagram. Because already I know that A, B are subsets of U. So the U is the rectangle, that is the universal set. Then A and B, of course, you can draw them with an intersection. Even if at the end of the day, you don't find the elements that are common, it doesn't matter. But in this case, when you want now to fill in the elements, you have to start at the intersection so that when you are done with the intersection, you then fill other regions. So in this case, A and B, we see that A2 is common. It's only A2 that is common, so we place that on the intersection. There the 2 is. Then after that, we can go on to place the other elements for A, remembering that A is the black circle. So anything inside the black circle is in A. So the 2 is already there. Then we go on to a 4, 6, 8, and 10. Then obviously you check, if you count how many elements A have, we have 5 of them. So you count 1, 2, 3, 4, 5. So we are done with A. We go to B. Of course, the red circle represents B. Anything inside the red circle is in B. So the 2 is already there. Therefore, we represent 3, 5, and 7. Then check, we have 4 elements in set B. So we count 1, 2, 3, 4. So we are done with representing A and B. But as you can see, these A and B are in U. That is the universal set. So what we need is go check the elements of U and see those that are not appearing in A or B and write them outside A and B. And that number is only 1, it's 9. All others are either in A or B. So we then write the 9, which is outside the 2 sets, such that now this is the complete representation of the information in the Venn diagram. So now we then go on to try to answer questions B up to F using the same Venn diagram. All what we want to do now, we are saying we want number of elements not in A, right? This is your A circle, the black one. So we want those elements, how many are they, that are not in A? You see that we have 1, 2, 3, 4, right? So the answer to that is 4. Then you go on to see number of elements in A and B. Already, I've already said A and B is the same as A intersection B. So we go to the intersection, we only have 1 element. So answer to that is 1. Then number of elements A or B, meaning O is representing the union of A and B. Union means we are bringing all the elements together, those that are in A and those that are in B. To simply do that, we count 1, 2, 3, 4, 5, 6, 7, 8. So they are 8. So D is 8. Then number of elements in A and B complements. In other words, understand this to mean we want the number of elements that are not in the intersection, that are not in the intersection. So this is the intersection. What is not in the intersection is 1, 2, 3, 4, 5, 6, 7, 8. So that will give us 8. Then F, we want number of elements in A intersection B complement. That means we want the intersection of A and those elements that are not in B, right? B is the red, right? So the elements that are not in B, we have this one and this one and this one and this one, then this one. But we want those elements that are not in B intersection, that those elements that are in A. And you see that the 4, 6, 10, and 8 are those elements that are not in B, but are in A. Then the 9, we are not going to consider it. So it's 1, 2, 3, 4. Okay, this is basically what it means to represent information in a Venn diagram and then work with that information answering questions. Let us look at another example. In a class of 30 students, 4 take both biology and science, 18 take biology, 7 take science only, and 5 take neither biology nor science, right? Let B be a set of those who do biology and S be those who do science. Draw a Venn diagram to represent this information. Then you use that same Venn diagram to answer to Roman figure 1 up to 5. So a solution First, the fact that already I know that 4 take both biology and science. So there is an intersection. So I draw my sets with the intersection. And the first thing to do is always fill the elements of the intersection so that you don't run into mistakes. Therefore, we place the 4, which is common for both biology and science, right? Now, if I am going to place 18 take biology, so all what it means is those who will be inside the red circle should be 18, meaning I have to place those that are taking biology only, right? So it will be 18 minus 4, I get 14. So 14 are taking biology only, but those who are taking biology, it's 4 plus 14, which gives you 18. Then I go on to those who are taking science. I'm told that 7 take science only. So all what it means is I'm not including those at the intersection. Those who take science only occupy this region. Therefore, to that, all what it means now is I place the 7 who take science only, and 5 take neither biology nor science. So all what it means, the 5 are not seen in biology or science. They are supposed to occupy any place outside the 2. So here are the 5 who don't participate in biology nor science, right? So as it is, if you want to check whether your representation is correct, if you add all these 4 pieces of information, that is 14, 4, 7, and 5, you should come back or reach the 30, because the universal set represents the class of 30 students, right? Now, let us use the Venn diagram to answer the question. Roman figure 1, right? Number of students taking biology or science, right? So that means I want all the students who are taking biology or science. So I add this plus this plus this. Those are the students who are taking biology or science. So basically, this is all what it means, and they are 25. And already I have substituted the or with the union so that you get used to the words, the union or the word or. Then Roman figure 2, we want number of elements, B or S complement. That means we want those who are not doing biology and science. That is what we mean. We are saying here are the students who are doing biology and those who are doing science. Who are those who are not doing anything? That's the meaning of this. So as such, you go outside the Venn diagram. I mean, outside the 2 sets B and S, inside the Venn diagram, and it's 5. So those who are not taking biology, no science, are 5. Or if you are not supposed to use the Venn diagram, should you realize that those that are taking biology, science are 25, but it's a class of 30, then it would have been 30 minus 25, you still get 5. But however, here the question would be just use the Venn diagram, but I'm doing that so that you learn something. Right, then Roman figure 3, number of students doing biology and science. These are the, and representing the intersection. So those who are doing both the subject, biology and science, are those on the intersection, and they are 4. Right? Then number, Roman figure 4, number of those who do biology and those who do science, and then you remove those that do both biology and science. That is all what it means. So let us do that. Those who do biology, if you go the red circle, they are 18. Those who do science, if you go the blue circle, they are 11. So in other words, we are saying this is represented by this, then the number of those who do science represented by this, then those who do science and biology, they are just 4, then minus 4, then you get the answer is 25. Then we go on to number 5, it was number of elements in the union, that is the number of students in a class, and with that, what it means, you add everything, 14 plus 4 plus 7 plus 5, and 30, which coincide with the number of students in the class. Then C is simply asking, what do you notice in 1 and 4? You see, in 1, we have 25. In 4, we have 25. So if the right hand side, we have 25, 25. So the left-hand side should also be the same. That means number of students doing biology or science is equal to the number of students doing biology plus the number of students doing science minus the number of students who are doing both science and biology. This is all what we make, and this is an important conclusion. Very important to know, because why? If we add those who are doing science separately and add those who are doing biology separately, like you are seeing here, we are adding 4 twice. We add, when we add those who are doing biology, then add again those who are doing science. This is why we try to remove another added portion of the same students, right? So this is why I'm saying it is an important conclusion. Okay, let us look at example number 3. In a class of 35 students, 8 take biology only and 17 take science, and the remainder take neither biology nor science. Let B be a set of those who do biology and S be those who do science. Draw a Venn diagram to represent this information. Then we use that Venn diagram later. Right, as you can see here in our problem, there is nowhere where it is indicated that there are those who are doing both subjects. This indicates that there is no intersection between those who do biology and science. So if I'm to start putting up the Venn diagram, set B and set S are not together. They don't have an intersection. Now, I wanted to place those who take biology, and I'm told there are 8. So I place the 8 here. Then 17 take science. So I place the 17 here. Right? Now, I'm done with that. What else do I need to understand? All what I have to do is now to check. I'm told of those 8 doing biology and 17 doing science. If I add these 2 numbers, are they going to give me 35? If they don't, then there are students in that class who are not taking biology nor science. Therefore, to that, like they said, the remainder take neither biology nor science. Then to find the remainder, we are simply saying 35 minus I add 8 plus 17, then the answer I'll get is 10. So the 10 are outside the 2 sets B and S, right? So here are the 10 students. So that now if I add the 8 and 17 and 10, I get my 35 students, because the universal set or the sample space is representing the students in the class. Now I'm going to use that diagram, Venn diagram, to now answer the question. Roman figure 1, number of those who do biology or science. In this case, we add 8 and 17 to get those who do biology and science. So exactly this is how it goes. Then Roman figure 2, we are simply saying number of those who do biology or do not do science, right? The biology and do not do science. You find that these are the 2, 8 and 10. So we add them, you get 18. Then number 3, number of those who do biology and science. You see that we don't have such who do both the subjects. So in such a case, it is simply equal to 0. Then number 4, number of those who do biology plus those who do science minus those who do both, right? So we add this and this, then those who do both is 0. So it will be 8 plus 17 minus 0, then it gives me 25. Then when it comes to number 5, it was a question of checking that the number of elements in the universal set, they add up to 35. Yes, they do. If you add this one plus this one plus this one, you get 35. Then the question comes, what do you notice in 1 and 4? In 1, we have 25. In 4, we have 25. So if the right-hand sides are giving us the same result, therefore the left-hand side should also be the same. So we can conclude that a number of elements in B union S is equal to number of elements in B plus number of elements in set. But here our elements are students who are doing biology and science, isn't it? So this is an important, again, conclusion as compared to the previous one, wherein we have to subtract those that are doing both subjects for reason that we would have repeated the addition. But in this case, there's no repetition of addition because there's nothing in common. So as such, we know that if we want to know those who are doing biology and science and there are no students who are doing both subjects, we simply add them separately to get the answer, right? But there is this question, what name do we give to sets B and S and Y? Right, the B and S are disjoint sets. Disjoint, that means they don't have anything in common, they are separate, right? Because this sign means because the number of elements in the intersection is equal to 0, or trying to represent that the number of elements in the intersection is 0, you could write that B intersection S as a set, it is an empty set. So sets that are disjoint means their intersection is an empty set. Okay. With that, that was basically what I wanted to let known in terms of given information, how I supposed to represent it on a Venn diagram. Then after representing that information in the Venn diagram, can you answer questions using the Venn diagram? And I think I have achieved